Hello and welcome guys. So this is another video about Golang. Specifically in this video we're going to be talking about throttling, how to implement it in Golang, why we need it, what kind of problem does it solve. And overall I think this is a very interesting topic and a nice opportunity for someone to practice once again Go routines, channels, concurrency, race conditions, all the good stuff in Golang. So you might be wondering what is throttling and what is this drawing in front of our face. So in this video, I'm going to be using a Leaky Bucket implementation. And obviously this is the bucket and it will make sense in a second. So this bucket is something that's going to be placed in front of our API. So let's assume here is our API and before it, we have this bucket. And let's assume the messages are coming in, like requests are coming into our server and we place them in the bucket, like a water being poured in a bucket. And here we have a hole at the bottom. And just like water, at certain rate, the water will be pouring out, right? So like one message got through to our API, then another message got through to our API. But the rest messages are staying in the bucket. Obviously, we can get a bucket overflow, right? So the messages won't go through. This is already a, you can talk about rate limiting. We're not going to be talking about this in this specific video. We will talk about how we can implement this leak logic and why do we need it overall, right? So what can happen? Let's assume we started our API and then we got some kind of burst in traffic. Then it slowed down. Then we got another burst. Then we got another burst. So we're getting some kind of bursty traffic. Why this might be a problem? That at certain burst, we will consume like way too much CPU, RAM, whatever, and our server will just crash out, right? We don't want to have this. We don't want to give our clients control of our API and the ability to crash it out. So we want to process messages, requests at only a specific rate, right? We want to smooth it out and consume it maybe longer, but we will consume it only at the rate we prefer. In this way, we can have a static basically consumption of RAM, CPU, whatever metrics is important for you. And this is essentially what this hole is doing, right? So we are allowing messages to come only at the rate we prefer, we set in our API, right? So one message go through, the rest is still waiting. So as you understand, we will use some kind of interval, ticker, and only at a specific tick, we will consume messages. And I have one more diagram for you to show. So this is more of a coding approach already. So let's assume once again, we have our client and a consumer, a server here. So usually what we do, we send messages directly to consumer to our server, but we will break this loop. We will place, basically this logic will be our throttler. So we will place some kind of input buffer, which is our bucket. We will have a ticker and an out buffer. So what will happen? The messages will not go through straight away to our consumer. They will go into input buffer. And then within this throttler mechanism, we will have a ticker, and the ticker only at the rate we set will check, do we have anything in the bucket? If we have, we will forward it to the output buffer, and output buffer will send it to our consumer. So this is essentially how throttling works. Now we don't send messages directly to the consumer. We check if we have a message, we will send it. And we are checking these messages, let's assume at rate 333 milliseconds, right? So we set the rate, and obviously buffer can have some kind of limit. Then if the bucket overflow happens, we can rate limits and some kind of error, whatever we like. But in this video, we will talk about throttling, and probably in the next videos, I will do a rate limiter as well. All right, I hope this was clear. Now let's jump into code. All right, guys, so I have a project from my previous videos, but it doesn't matter which project it is. We can use throttling for HTTP, and I will show you, basically we can use generic types and apply it anywhere we want. But here I have my WebSocket project. I did it previously. If you're curious, check my previous videos. But once again, it doesn't matter. So let's build our throttler. So what we need to do? So we will create some kind of struct. We will call that a throttler, and it will have input channel. This will be a channel of request message, and request message. Once again, I'm using a project here, so I have message type, data, room ID, and client, right? So this is this can be generic. You're sending just some data, the rest doesn't matter, right? Nevertheless, I have already a request message. If you're using HTTP, it can be something different, but once again, it can be generic. So we have input channel, we will have output channel. I will explain it now, and we will have some kind of rate, and rate will be time duration, right? So the input channel, basically, we are building a pipe, right? We will be sending messages into input, and once the message can be processed, we will send it into output. That's why they are same type. we are not changing message in any way. And how often can we send a message will be determined by the rate. As simple as that. Do we need anything else on the throttler? I think not. If we will need it, we will add it. So now let's add the main function with the logic. So this will be leak, right? Since we are doing a leaking bucket implementation, we will call the function leak. And what we need to do. So here we will have an infinite loop. And in the infinite loop, we need to check if we can process the message. For that, we will create a ticker. So we'll create time new ticker, and it will have t.rate. And here we will just do select case if we have a t. I created t and t. Okay, let's make it ticker.c. If ticker.c channel, meaning we received something, and now we'll do another select. Actually, do we need to first select? I think yes, we will do it just for jumping ahead. Exit, we will have some kind of channel for exiting this Go routine, right? So here we will have straight away for cleanup. If we have something in the exit, we will return. And in the ticker, now we need to check, do we have something in the input channel? If we have, so this will be our message, right? We are checking input channel. Do you have anything? If yes, we're just sending it to the output. And this is pretty much it. If we have nothing, we will say just default case, and here we don't need to do anything, right? We're just skipping. And this way, as you can see, we are on every tick, we're checking, do we have message, do we have message, do we have message? So this is the way we are limiting essentially the throughput, because we are processing messages not as they come in, but when the ticker hits this select statement. All right, and in default, let me just add, if we have a message run in n, let's say like 10%, it's less than 1, we'll just fmt println no messages in throttler skipping. So it wouldn't spam way too often, right? Just like 10%. What else we need? We need to create actually, we need the function to create a throttler. So this will be new throttler, and obviously it will return our throttler. What we need here? We need to create a rate somehow, right? So here we will pass messages per second. This will be an integer. So how we will create a rate? We will take time second and simply divide it by time, not time December, time duration, message per second. All right, so we are sending how many messages we want to process per second, and we're dividing second by this duration, and this is how we get the rate. So we'll return our throttler, and we will create input channel, make channel of autocomplete, nope, yep, of our request message. Let's allow like 64 messages for a burst. We will create output channel the same way, and we will set rate to our rate. And this is pretty much it. The only thing we need to actually leak. So I will say t equals to the throttler, and we will say go t leak. And here we need to provide exit channel. So I will give it here as well. This will be channel struct. So this is for cleanup. Can we provide exit channel somehow differently, or I don't know, context? Yes, we can do it, but for now, just for simplicity's sake, if we need to clean it up, we can do it other way around, somehow differently, right? But for now, I'm just passing exit here on the new. And what we need to do, we need just to return t. And I think this is it. This is the entire logic. Let's think how we can add it, right? We will add it to our client. So I will place a throttler per each WebSocket client. And if some client is sending way too many messages, we'll basically throttle him. So let's add a throttler here. This will be throttler and the pointer. And we need to create him here. So throttler, let's create some kind of t will be new throttler, and we need to provide messages per second and channel. All right, let's create some kind of default value. default message per second equals to, let's say, 3. And throttler, so it will take default messages per second, and we need exit channel, so we need to create first our client. And we will remove throttler from here. Let's drop throttler to display. So this will be c.done. I'm using already this channel to close the client, so we will use the same client, the same channel to close the throttler. And now c.throttler will be equal to t, and from here we will return c. All right, so here I have a read message loop. What it does is it reads from WebSocket connections and basically gets the messages, right? We are receiving bytes, we converting them, basically unmarshalling them, and then, well, preparing the message, right? This request message, which I'm expecting in my throttler. Once again, this can be generic, data can be something different, message type, you can play around with it. Yeah, that's not important. The important part that here we are pretty much done with message, right? It's ready. And now here we are processing it. So I will remove this part from here and we will create a function on our client, something like handle message. And here we need a server. So we will give message here, the same request message. Actually, I think we will do it on the server. Server, this will be our server, not the client, because it's the same. And yeah, looks good to me. And then we will create actually on the client. Throttler loop, something like this. Throttling loop. I don't know. Let's create throttling loop. And it will take in the handler, right? So the same handler. Let me just copy it. So we can make once again this generic. So this will be handle message func like so. Do we need infinite loop here? I think yes. So let's do select case if we got message from our output. So this will be c.throttler output channel. We'll handle message and provide this message like so. So essentially this is a decorator on top of our existing logic. And I think we actually don't need a select statement here. Right? We will just, this will be an infinite loop. Okay, we need a select statement because in case we are c.done, we need to exit this as well. Or we can do just like so. Just in case, if not okay, if we don't have any messages, we will return as well. And this reminds me that we need to clean here as well, defer func. And here, if we are exiting, we will close input channel and output channel. Because yeah, we need to clean up all of this as well, all those channels. And I think this is, this all looks good. Now, so what we do here, instead of processing straight away, we will say that c.throttler.input channel, we will send this message, right? So we are starting the pipe and we need now to start this in Goroutine, which will be the output of the throttler. So we will do it somewhere here. Go see throttling loop, and we need to provide the function, and we created this function handle message. And this is not S, this is SRV. Okay, so our throttling loop is essentially a decorator on top of our handle message, which we had before. So once, as I said, you can do the same for HTTP or something else, or whatever logic you have, right? You can just decorate it like so. And actually, we need to take care of one more scenario. What if we are closing our client, the connection dropped out, and we need to, and we still have messages in our bucket, right, in our input channel. So we cannot close it straight away. We cannot return here straight away, right? We will need to close it and drain out all the messages. And what you will do with messages is up to you, right? But here we will need to, basically we can store them, and once client reconnects, we can send it to him, we can send an email, we can do whatever we want. But here we will just t.input, we will say this will be a message. So we are closing it, right? We are not accepting anymore. We are taking the message, and here we will just printf draining message. And let's do -v, and this will be a message. All right. Now we are draining connection, and yeah, and we also need to clean up the ticker as well. What does it have? Ticker.stop. Yep. We are not ticking anymore. All right, now it's actually looking good. Let's just do one more log. Println, draining, done. Now let's test it all out. Let's write a client in our test and see how it's going to work. Just a brief pause. If you enjoy this type of content or want to watch me live code projects like this, hit subscribe button and ring that bell. It is free, takes 2 seconds, and helps me a ton. As you can see, only a very small percentage of you guys actually subscribe to my channel. Anyways, thank you very much for all the support. Let's continue. And I actually think I already have a pretty good test for that. So we have wrote before test connection test, which basically we connect to the server, send the message to the server, and server sends back the same message to us, to all the clients. Right, so we're connecting 5 clients, and we send message to 4 clients except the one who was sending. So I think this will be perfect to just test it out that we didn't break anything. Let's just run it and see how it's going to work. So clients all joined. No message in Throttler. Then we send 5 messages at the same time. We received. Nevertheless, I don't see any errors. I see that draining done for each client. And we are exiting test, right? All the clients left. Now let's add some breakpoints and see how it's actually working. So we will place a breakpoint in here. So once again, how our throttler works. When we get a ticker, right? When the tick happens, this select statement will be executed. And then we are checking if we have a message in the input channel. If we have it, we will send it to the output. If we don't have anything, we just execute the default, right? And we are leaving this select statement. And on top of this select, we are just waiting for exit. If there is exit, we are doing cleanup and everything. And on top of that, we are doing this in for loop. So this is infinite loop. We are checking every single time, right? So we are waiting for either ticker or exit. Whenever something happens, we start executing their logic. All right, so we are supposed to, then we should be hitting the false statement because the rate at which we are sending messages is higher than the rate at which we are supposed to consume them. Actually, what rate did I set? Let me check. 3 messages, right? 3 messages, but let's say here 5. So we will send 5 at the same time, and we should throttle them, basically. And actually, we will be sending from 2 clients, right? So we will get way more throttling, and then we filter out the client who is not supposed to send any messages, but we don't know it at this point. So we will be sending essentially 10 messages. And well, 3 messages per client, so we will throttle overall. 4 messages will be 2 per each client, so 4 messages in total will be delayed. I'm not sure that we will hit default exactly 4 times, maybe more. Nevertheless, let's place message here, debugger here as well, breakpoint, sorry. And then in the main, let's add in handle. I don't think so. Let's add here. I'm curious what's going to be hit first. Done. Probably done will be hit first. And and let's add breakpoint here to see that we are consuming messages from the output channel, in fact, as it's supposed to be. All right, let's debug it. Remove this thing here. All right, we hit straight away default because I think clients are still joining and the ticker already checking our bucket, right? No messages. So we have 2 clients. We are checking. Okay, we sent a message already. I'm not sure why wasn't a hit here, but nevertheless, we already received a message. Is it a valid message? Yes, we got a broadcast. Make this a bit bigger. Broadcast data. Hello from test. Okay, everything as expected. Maybe this is... Okay, now we got into here. Not sure why I didn't hit this previously. All right, now it's working as expected. We are getting messages. We are hitting default, right? So we are throttling messages. Now the client starting to leave. They make 5 clients. I have 2 clients. Why am I getting so many clients left the server? I get 3 clients. Ah, I'm creating one more client for broadcast. Sorry, yeah, my bad. We don't need. So we were sending 15 messages in total. All right. That's why we are hitting default so often. Okay, looks good to me. So we connected 2 clients for, this is a receiver clients, and I forgot that I'm making additional client who will be broadcasting. All right, the logic looks good to me. Let's now add one more test, which will check that we are in fact sending messages at the expected, we are allowing to send messages at the expected rate. And if it exceeds, we are throttling them. So let's add a function test throttling. And it will be pretty much the same, right? We just need to add a timer, I think, in here, right? So we dial the server, we connect it to all the clients, and what dial server does, if you're curious. So here we are connecting via WebSockets, we are dialing, we will skip these 2 coroutines. Here we are just reading messages, and whenever we get a message, we increment a counter, message count, right? So we are just calculating all the messages we received. And when we received exactly number of messages based on the target, which is equal to the target message count, and target message count is number of messages multiplied by number of broadcasts. So once we received all the messages we are supposed to receive, we are just closing, exiting, and leaving this go routine and basically removing the client. And then in here we are sending messages. We have our broadcast client, and we are sending based on the broadcast count the messages. And I think once we connect it, we're sleeping here for 1 second to make sure that everyone is connected. We are good to start the timer here. So this will be start time dot now. And when will our test finish? I think we will need to check duration after the wait. So the duration will be time since. I love this so much that Golang has by default all this functions on time, and time is default library. So nice. Times instance. So we're getting the test duration. And now we will cancel everything. And let's print here fmt println. Let's make it beautiful. Test results. Something like this. And here we'll say what we need to calculate. Actually, let me think one more time. Like minimal duration. Min duration, and we need to be greater than this minimal duration. So the min duration will be time duration, and we need to check how many broadcasts we did. We need to do float 64 of broadcast count, and we will divide it by the number of messages we allow per second. So this will be once again float 64 default messages per second, and we will multiply this by time second, right? So we are checking duration at which we allow, at how many messages we allow to send per second, and we multiply this by second. So this is the minimal duration the test is supposed to take. And let's println test printf test duration. Yeah, let's make another one. This will be the duration and min duration. It will be min duration. And let's do an assertion. Assert. So it should be greater or equal. So our test duration should be greater or equal than min duration. Messages got throttled. And I think this is pretty much it. The only thing I see that I made a typo, test results. Let's make something like end of the test. And after that, we'll make an assertion. Messages got throttled. The only thing I know this time we need to make %v, otherwise it's going to be one huge number, and otherwise it will convert to seconds. All right, let's do the test and see how it's going to work. The only thing, let's make a bit more client, like 10 messages, 20 broadcasts. Otherwise, it's going to be, yeah, very small sample. We're not going to see the difference. All right, I might have made too many. All right, as we can see, test duration is 7 seconds and mean duration is 6 seconds. We got 1 second difference. Quite a lot, actually. Ah, I know where I'm making a mistake. This is a test mistake. This is because we are sleeping here for 2 seconds. Let's make this 100 milliseconds. So we are checking messages every 2 seconds. Let's run it one more time. Actually, let's make a throughput a bit higher, right? So the test runs faster. So you don't need to... let's make 10 messages and see the difference, how it's going to be now. All right, we can see straight away it's running way faster, right? We allowed way more messages. And as a result, now it's, yeah, they got pretty much the same result. All right, as you can see, we are throttling messages. We are allowing, so the minimal duration, the messages should take 2 seconds, and our test duration took a bit longer. So in fact, throttling is in fact working. All right, I think this is it for this video. I hope you enjoyed it. The code will be available in the GitHub repository. All right, thanks guys for watching. I will see you in the next one.